I want to show you next is a more sophisticated way of doing it, and it's a more useful way, because the problem with doing this is you literally have to write a table to work out a whole lot of values. There are some advantages to this, because you might get a slightly different question where it is something along the lines of, you know, this is the amount of interest that you're earning, or maybe that you're paying on a loan. What if you have an extra amount that you're adding each year? And that's something that you can easily do in a table. If there's an amount you're paying off a loan or something like that, it's a lot harder to do in the equation form that I'm about to show you. Okay, so this is a more useful way of thinking about compound interest. In some respects, like I said, there are some limitations. What we've got to think about is a slightly different way of thinking about the amount that we're calculating. Now, you know that the amount that we had after 1 year was the principal times the, or plus the interest, and so that gave us our new total. So what we've got is the amount equals principal. Now, another way of writing that it's the principal plus the interest is saying that it's the principal times 1 plus the interest as a decimal, so 4.5 over 100 in this case. So if I was to simplify that a little bit, it's going to be the amount equals the principal, principal times 1.045. Okay, hopefully you're with me so far. Now, the next year, so this is, I call this amount 1, so that's after 1 year. Amount 2, now you remember that when I'm calculating the interest and stuff, I'm using the amount from the end of the first year. So amount 2 is going to be amount 1 times 1.045. And then when I get to amount 3 at the end of the third year, it's going to be amount 2 times 1.045, which I probably don't need to leave in brackets. Anyway, now, here's the important bit. What you've got to remember is that amount 3, when we're looking at amount 3, it's amount 2 times 1.045. But remember that amount 2 here is actually amount 1 times 1.045. So I'm going to replace this value here with this part of this equation. So amount 3 equals amount 1 times 1.045, and that's all times 1.045. Okay. Now amount 1 came from up here. It was the principal times, or with the interest added on, or the principal times 1.045. So I'm going to put that in here. So I'm going to have principal times 1.045, and this is times 1.045 from up here, from the second year, and it's times 1.045 here for the third year. So, something interesting has just happened. I've got the amount after 3 years is the principal times 1.045, which is the way we're adding the interest on, to the power of 3, because it's 1.045 times 1.045 times 1.045. Now, if I was to do this a fourth year, all I'd be doing is multiplying my amount by 1.045 again, so it would become to the power of 4. So we end up with a general formula for compound interest, where the amount after, now I'll just change my pen colour so that it looks, I don't know, looks official or something like that. I'm going to write it over here. So the amount after X years is the principal times 1 plus the interest rate over 100 to the power of X. And so as long as we're not doing anything, woo, that was not a straight line. As long as we're not doing anything tricky with these questions, like paying a certain amount off the loan each month or anything like that, if we're just doing a straight calculation of the interest that we would earn in over a number of periods of time, then we can use this. We can always use this formula. So, tell you what, we'll go over to. Actually, I don't think I have a blank page. In fact, let's just go back to our previous example, our previous page, and you can see how we can just apply this directly to work out the answer over here. Now, I know that I could look at the spreadsheet and I could check the answer, but let's just do the calculation here. So we were asking about after 5 years, so amount after 5 years equals a principal. So in this question it was 5,000 times, now 1 plus 4.5% over 100, so it's going to be 1.045, like we said, to the power of 5. Now obviously this is not something I can work out in my head. I don't think many people could. So at 5,000 times 1.045 to the power of 5. If you need any help learning how to do this stuff on your calculator, just ask and I'll let you know. And what I get is 6,381 and 41 cents. And just to double check, I'm going to pop back to my spreadsheet and go up to, whoa, hang on, that's not the same. Okay, I'm confused. 1,000 times 1, that's because I did it wrong on my calculator. Alright, my bad, I did a typo on my calculator, I did 1.05 instead. So what I get is 6230.91, and when I pop back to my spreadsheet this time, you can see that when we look up at 5 years, that's exactly the value that we got. Okay, hopefully that helps you to see a little bit more about what we can do with compound interest. So this is an above the standard thing, and hopefully you can also see that we are doing something here that we've just done from our previous topic. So what we are dealing with here is indices. So this is an application of indices, and also it's an application of logarithms, as you'll see shortly. Alright, any questions, send me an email or ask me about it during the week. Thanks.